In this video, we'll be predicting the products for a double replacement reaction. And once again, we can use cartoon chemistry to help us out. So we have two couples dancing. Here's the first couple and the second couple. Now what's going to happen is this guy is going to leave his partner and he's going to take the place of this guy. And this guy, he gets booted out and he goes to where the first guy was. So essentially, they've just switched partners. That's it. So in this reaction, we have sodium sulfate added to calcium iodide. Now there's two types of double replacement reactions that you'll be responsible for. The first kind, two soluble salts switch partners to form a soluble salt and an insoluble salt. And secondly, we have a neutralization reaction where an acid and a base react to make salt and water. So what type of reaction do we have here? One like the first example or like the second example? Well, you can see we don't have acids or bases, so it's going to be more similar to the first example. So like we said, these guys are going to switch partners. I like to think about the cation, or sodium, coming in and bumping out the cation here. So instead of calcium iodide, we'll have sodium iodide. And calcium, when he gets displaced, he'll move over here where sodium was. So instead of sodium sulfate, we'll have calcium sulfate. Now we'll want to write the formulas, of course. And now let's read what this states one more time. Two soluble salts. So let's make both of these salts aqueous or soluble. Switch partners to form a soluble salt and an insoluble salt. So let's see which one of these is soluble and which one is insoluble. So let's look up sodium iodide. Let's look up the sodium. Well, you can see that sodium is soluble and there are no exceptions. So we can write AQ after sodium iodide. We also have to check the second salt because we can't just assume that the second one will be solid or will form a precipitate. We actually have to check that. So let's look up calcium sulfate. We see here that sulfates are also usually soluble. However, there are some exceptions, and one of the exceptions is calcium sulfate. So calcium sulfate will not be soluble in water. That means it will be a solid or will be a precipitate. And of course, the last thing we'll want to do is we'll want to balance this equation. We have two sodiums on the left, so we need to make two sodiums on the right. That made two iodines on the right. We already have two iodines on the left. We have one calcium on the left, one calcium on the right, one sulfate on the right, and one sulfate on the left. So this reaction is complete.